Good morning, everyone. I'm Judith. Today's presentation focuses on how researchers are making chemical processes greener and more efficient. This team has developed new ways to prepare important compounds while keeping environmental impact in mind. The researchers looked at compounds that work as insecticides. What makes these molecules special is a particular chemical group, the CF3 group, which helps them work better in biological systems. They used a technique called flash vacuum pyrolysis. Let's call it FVP for short. The conditions had to be very precise. They worked with reaction times between 2.9 and 5.3 times 10 to the -2 seconds at very low pressure, about 0.02 Torr, and temperatures from 200 to 375 degrees Celsius. The team used several ways to measure how green their processes were. Think of it like a report card for chemical reactions. They looked at things like how many atoms from the starting materials end up in the final product, how efficiently they used their materials, and even gave the reactions a kind of environmental score using something called the EcoScale. They also used a neat visual tool called the Green Star Rating. It's like a spiderweb diagram showing different aspects of sustainability. Looking at their results, what's really interesting is how temperature changed things. The team tested 5 different compounds, labeled 1A through 1E. Each compound behaved differently as they turned up the heat. Some worked best at lower temperatures, while others needed more heat to react. They found they could control exactly what they were making by carefully choosing the temperature. When they crunched the numbers on how green their processes were, 2 compounds stood out. 1E and 1A performed best across all their measurements. These showed excellent yields, that's how much product they got, and created the least waste. The results are right here in this table, showing everything from yield percentages to something called reaction mass efficiency. The team reached 3 main conclusions. First, they found that 2 of their methods, the ones making compounds 1E and 1A, were clearly the most environmentally friendly. Second, they identified areas where the other methods could be improved. And finally, they showed that this pyrolysis technique can be a really good way to do green chemistry. This work builds on previous research by several teams. The key papers that laid the groundwork were published by Pelaez and Pinho e Melo back in 2013. And more recent work by Sheldon and others has helped shape our understanding of sustainable chemistry. Thank you for your attention. The team will be happy to take any questions about this fascinating research by email. You can find them at www.sscon.org.